All right, and so it becomes quite fascinating when it comes to simplifying trig expressions. So in this video, I am going to show everybody a few examples of how we can simplify the trig expressions. A trig expression is any of those expressions that involve entirely the trig functions, and fundamentally those six trig functions that we've studied. All right, and so in this example, we are going to simplify the expression secant of theta over tangent of theta. And so secant of theta is known to be 1 over cosine of theta. And on the other hand, we already knew from the denominator here that tangent of theta, any angle theta, is defined as sine of theta over cosine of theta. And therefore, this overall expression from start, secant of theta over tangent of theta, we can rewrite it as, first in the numerator, we're looking at one over cosine theta, and then that fraction there is being divided by sine theta over cosine theta. And so now what we have here algebraically is two fractions. One fraction in the numerator divided by another fraction in the denominator. And so algebraically we can rewrite this as 1 over cosine times the reciprocal of sine over cosine, which in turn becomes cosine of theta divided by sine theta. And so now recognizing that we have the common factor cosine theta right here, then I am going to cancel cosine theta. And so now the next step here, we are reduced down to 1 over sine. So at first we thought that we are quite simplified, and seems like nothing else we can simplify. However, we can rewrite this as a cosecant of theta, and that's making it even more simplified. And so this final ending point right here is where we finish with our simplifying problem. We simplify an expression that starts out being secant theta over tangent theta, and we simplify it down into only an expression that involves one function and being only one operation, the cosecant. All right, and in a different example, let's simplify the expression 1 plus cotangent of, and let's say we have been using theta for a long time, so why don't we switch to using a different variable's name? So how about a cotangent of x divided by 1 plus tangent of x. And let's figure out a way to simplify this. And so the reason we need to simplify, because this starting expression, first of all, it involves a lot of operations. We got fractions, we got adding terms in each of the numerator and denominator, and we have more than one trig functions being involved here. So the idea of simplifying now is that, is there a way we can bring it down to an expression that has the least number of operations, and also involving the least number of trig function, maybe just down to 1. All right, so once again, as a reminder, cotangent of x is defined to be cosine of x over sine of x. So that's just something to keep in mind as a precaution before we proceeding, or as just simply a reminder. Precaution might sound a little too serious. And tangent of x as a reminder, being defined as sine of x over cosine of x. And so in that way, my starting expression is 1 plus cotangent of x over 1 plus tangent of x will, so now we're simply going to substitute what we, that reminder about how we define tangent and cotangent in their places. So 1 plus cotangent now is being substituted with cosine of x divided by sine of x. And then the denominator here, 1 plus tangent of x, will become 1 plus sine of x over cosine of x. And so it seems like so far I'm actually making the expression a lot bigger, but we will see how it turns out in the next step right here. And so, and I don't need this information anymore, so let me erase that here to make some more space for myself. But so now we do need to use the algebra here, and being into this class, my sincere advice here is we need to get your algebra skill going. And so we're going to make a common denominator. So my term 1 right here, I'm going to rewrite it as a sine of x over sine of x, and plus cosine of x over sine of x. And that's hopefully I'm trying to remind somebody about some general skill how to make common denominator here. And here in the denominator, my term 1 right here can also be made into cosine of x over cosine of x, and plus sine of x over cosine of x. And I shouldn't skip the parentheses here. And so now having common denominator in both big numerator and denominator and big denominator, then I'm going to turn my two terms of my big numerator here into sine of x plus cosine of x, two terms but over one single denominator, sine of x. And my big denominator in here is going to be cosine of x plus sine of x all over by cosine of x. And so we have quite a complicated expression here, but it's going to turn out a lot better later on in the next step. But now a fraction in the numerator divided by another fraction in the denominator here. So what I'm going to end up with is being sine of x plus cosine of x, and dividing that by sine of x. And I'm going to multiply with the reciprocal of the other expression. And that leads me to having cosine of x here and divided by cosine of x plus sine of x. But what I recognize now, and allowed me to use a red ink right here to highlight, but what we recognize now is that these are common factor. And so now we can cancel them out. They'll get canceled out, the whole two terms. Because the two terms here exist as one factor. And so now after canceling the cosine of x plus sine of x away, then we're looking at simply cosine of x over sine of x. And so all of a sudden, the very ugly looking expression here involving a lot of operations and two functions, and two trig functions, now all of a sudden reduced down to having only one division sign and then two trig functions involved. And we're still not quite happy. Is there a way to bring this down to having only one trig function involved? So that brings us down to cotangent. Simply come straight out from the definition. And so here we should be happy with our final simplified answer. And in a different example again, let's look at simplifying 1 minus about sine square of x, and divided by sine square of x. So this starting expression here has a certain specialty that I brought it up for a reason here. So first of all, remind yourself about the Pythagorean identity, that sine square of x plus cosine squared of x equals 1. So right from this identity, you always have your choice. Number one, you can subtract cosine square from both sides of this identity, because in the end, an identity is an equation. So you can always have your choice, like I said again, you can always have your choice to subtract that cosine square from both sides. So this is what we consequently end up right here. Sine square of x equals 1 minus cosine square of x. And so this is actually a little identity as well, and quite commonly used out there. From the same Pythagorean identity, you can also subtract sine square from both sides, and you can arrive at cosine square of x equals 1 minus sine square of x. So we have this thing, we arrive at this little identity by simply, again, subtracting sine square of x from both sides of that identity. And so as I keep pointing out more examples and more examples, once again, this is the reason why I keep calling this identity, even though it has the name being a Pythagorean identity, but I keep referring to this as the fundamental identity, because a good majority of those other identities are being derived from this identity right here. And it's, once again, it's going to be quite useful in this problem, because now, along with what I was trying to explain, we now recognize 1 minus sine square to equals cosine square. And so that becomes useful. 1 minus sine square of x over sine square of x. 1 minus sine square is the same as we just learned at here. So now we can turn that into cosine square of x. And over sine square of x. And so, and that becomes maybe let me do this one more step here. I'm gonna, if we recognize that there are two like powers here, square and square in the numerator and the denominator, and so I'm gonna rewrite it as one fraction cosine over sine inside of a square right there, in case anyone viewing this video is still not making that connection yet. But now cosine over sine is clearly, and inside of this bracket, cosine over sine is the cotangent of x, being square. And now cotangent of x square, the shorter notation for that is cotangent square of x. And we're done simplifying another expression right there. We brought it down to only one operation and being only one function involved. And here in this example problem, we have another expression to simplify. So what we have here is sine square of theta minus cosine square of theta, and we're dividing that by in a fraction with sine of theta plus cosine of theta. And so I brought up this example in the purpose to remind everybody that everything you have learned in algebra, including that skill about factoring, can be carried out in here in this problem as well. And so notice that sine squared of theta minus cosine squared of theta, by first look it looks pretty fancy, but in the end it's a difference, and each one of these is a square. So what I see, the way I see it here, is a difference of two squares. And so a reminder from algebra that we actually have that famous a square minus b square. It's a difference of two perfect square. So anytime you run into the difference of two squares, it can be factored into a factor of a and b, but one of them is a minus b, the other factor is a plus b. Simple enough. And so that identity in algebra is about to be used here. And so starting with sine square theta minus cosine square theta divided by sine theta plus cosine theta. Then I am now going to factor out my expression in the numerator there. And so directly using that famous identity in algebra, the difference of two squares here, then I'm going to produce sine of theta minus cosine of theta in parentheses and multiply with, and see, just like that, the difference here, and then the two terms a and b being, the powers being reduced down to power 1, and here I'm going to produce another set of parentheses, and sine of theta and cosine of theta, repeat it, but with a plus between them. But now as soon as I finish factoring it out, then I realize right down here in the denominator there is another identical factor. And so like factors got cancelled away in this fraction. And so what we have left now is sine of theta minus cosine of theta. And that is, so I have to admit, here we won't be able to move on any further in a sense of bringing it down to only one expression, but this is at least, it's involved the least number of operations between the two trigonometric functions right here. And so this is the point where we finish with our simplifying problem. All right, and so sadly this video lesson is limited to only 4 examples, but there's still a whole world of trigonometric expression to simplify out there. The reason I end here at 4 examples is because you haven't seen enough learning in trigonometry, but as we progress through the quarter, there will be more expression that involves a slightly more complicated expression in trigonometry. So one thing to keep in mind that there's always more than one way to simplify a trig expression. And so after making this bottom line right here, then I highly recommend that any of you who view this video lesson of mine, feel free to retry those problems in your own thoughts, come up with your own approach to simplify the expression. And of course, my solution that I gave here, my method of simplifying here is not the only method. My approach for simplifying each problem here is not the only way.